All right, we're looking at topic 4-3. You've gone through example 1, made it through the triad, and so now we can move on to example 2. Example 2 simply says simplify the expressions. We're going to use the techniques that you were looking at in the last one. The only difference here is they're going to throw some rational numbers at you with some fractions and some decimals, but it really doesn't change anything. It just means you have slightly more complex numbers to work with. Now, before we actually jump into this, I want to rewind just a step and look at the last problem that you did in your example here. And here's a little tip that I personally find useful when working with these ideas. And I talked about it in previous videos, the idea of algebraic addition. And when it comes to moving terms around, it's really, really important to include everything that's a part of the term. And they did that. They showed it correctly in the video. But I want to make sure you don't make that mistake on a regular basis. So here's the technique. Algebraic addition, right, allows you to use the additive inverse. And the first thing you want to do, and this is almost a foolproof way so you don't make a mistake, is you take all of your terms and you put them in parentheses, including the symbol in front of it. So you can't think of this so much as an addition side as much as this is a positive 3c. Just like this isn't a minus 5, it's a negative 5, right? And then this is what they are not explaining to you, is that you saw them rearranging it so it looked like 2c plus 3c minus 4c minus 5 plus 7. That's what they rearranged it as. But they didn't really explain. They said commutative property like we said in the past, but why are you able to do that? It's because you use the additive inverse and make it boom, 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 algebraic addition. So separating out those terms. And from there, then you can start to use distributive property and different things like that to solve things and pull things out according to the different terms. All right. So if we apply that principle then as we get into example 2, we want to make sure we do that. So we're going to first of all separate out our terms. So we got negative 3, right? And then I'm going to put a plus. I like to put it up higher. That way it doesn't kind of interfere. Right? My next term is a negative 1/3 x, and a plus. And right, technically this is a plus, and they already have the next number in parentheses for us. So we just leave it in parentheses like that. And so we go like that. I mean, you could put a plus sign, but it'd basically just be a plus, which positive plus positive is still remains positive, but then the negative in the parentheses is what really matters. All right, plus sign up here, and then negative 1/5 x, like that. And now, to me, it's easier. You can see the terms, right? You can start putting things together. You can say, okay, got a negative 1/3 x, and negative 1/5 x, and those are going to go together. And I'm going to add those together to a negative 3 and minus, like that, right? And here's where those parentheses really can come in handy, because now we see that a negative third plus a negative 4.5 is that negative. We can solve for that and get a negative 7, and 7.5, right? Okay, so I'm just kind of talking to myself. I apologize. Let's get to business. Here we go. All right, so we got solve for this. All right, we solve for that. We said that's negative 7.5. I'm running out of space. I got to go to another sheet of paper or something. What are the benefits of this, right? So I combine those, got negative 7.5. Then I come back here, right? So we got negative 1/3 x minus x. And so if I come here, I'll just write that up here. I'll show you what I'm doing. X minus 1/5 x. That looks like an 8.5. Man. Right? So we take the x on the outside, right? That's distributing it out, and that leaves negative 1/3 minus a 1/5, which when you're subtracting two numbers, that's like adding them together. So to add them together, we need a common denominator, right? Here's that rational number, extra steps. So common denominator is going to be between 3 and 5, 3 times 5 is 15, so let's use that. So 15 and 15 for our denominators. There we go, give me a little more room. So that's times 5 here. So I got to multiply times 5 on top. So 5 fifteenths, and then times 3 down here, times 3 up here. So that's 3 fifteenths. So a total of 8 fifteenths as such. So 815x minus 7.5. Let's see if I'm good at math or if I need to go back to school. All right. I think they made a mistake. Yep, I'm seeing it. Okay, so looking at their problem then, here is their mistake. Did you find it? Okay, this is not the correct answer. We got the correct answer. This is not the correct answer. We got the correct answer, right? See how they have a negative 1/3 x right there? Now look right below it. See how they made it positive? How did it get positive, right? It was never positive. In the book, if you look in your book, you'll actually see that when they rewrote the equation on the first line, they changed it to a positive 1/3 x, which is why the work is so wrong. Oh, we got to call them up and tell them you made a mistake. We want a refund. I don't know what they would actually give us, but that's a pretty big mistake. That would really misguide students because it's just like sitting right there. But it's wrong. It is so wrong. We did it right. Trust me. We did it right. They did it wrong. See? Negative 1/3. Now they made it positive. How did it get positive? It didn't. It can't. Alright? So, correct answer is negative 8 fifteenths x minus 7.5. Boom. See? Even smart publishing companies make mistakes sometimes, but we're smarter than them. We totally, what's the word nowadays? We totally owned them. Alright, I'm going to stop talking cool. Move on. Alright, that puts us at the end of this lesson then, and I'm really feeling really good that I found that mistake and I can just, you know, but you go ahead and work through that. Remember to use that technique. I think it's golden. Right? Putting those parentheses around your terms and working with that, that's going to definitely help you, and make sure you don't make mistakes like the book did and not take a symbol with you. Alright, that's all I have for today. Bring your questions and concerns and anything else you might have about math, and we'll see you in class.